My PPT is visible, anyone?
Yes, sir, visible, visible.
Okay, okay, thank you. Thank you, Dr. Mukherjee, and good morning, all of you, participant of this particular FDP. Today, I basically talk about IoT-enabled wireless sensor network and its application. It is not a talk. We just basically discuss some open issues related to IoT-enabled wireless sensor network. And after that, I will also discuss some solution that we have proposed for open issues. Okay. And if you have any question, then you can ask your question between the talk, and you can also ask question end of this discussion. Okay. Now, this is the outline of my talk. First, I will discuss basic introduction about IoT. You have learned lot of things about the IoT in last few days. However, I try to briefly describe IoT. Okay. After that, I will also discuss about the basic concept of IoT enabled WSN. And after that, I will discuss some theoretical development regarding the IoT enabled WSN. And end of this talk, I will also discuss some hardware development related to IoT and how these hardware components are basically used to solve real life problem. That will I also discuss. Now, before going to details about the IoT, first we briefly understand what is the meaning of IoT. Okay. Because nowadays what happened that most of the people, those are basically belonging from technical background, they are basically talking about the IoT, Internet of Things. Okay. Now, what is the meaning of Internet of Things? Okay. Now, if we just try to understand in simple language what is the meaning of IoT, then IoT is nothing but a new form of internet. Okay. You can say that internet is basically coming in a new form with more application. Okay. Now, whenever we're talking about the IoT, objective of the IoT is to connect each and every physical object to the internet. Okay. That means if we capable to connect each and every object to the internet, then we can say it is an IoT, Internet of Things. Now, please remember one point whenever we're talking about the IoT. Okay. If we want to connect a particular object, physical object to internet, there must be some objective. Okay, why we connect a physical object to the internet? Otherwise, there is no meaning of IoT. That means if we modify our previous definition or previous whatever you can say that I have told you that whenever we just connect a physical object to the internet, if this statement we basically change, then we can say IoT is basically connection of physical object to internet to fulfill some objective. Okay, that's why I have written here that transfer things means what? That physical object of the real world into the smart device. Okay, that whenever we basically connect different physical object to internet to fulfill some objective, then our physical object is basically treated as a smart object. Okay. Now, Suppose that we just basically take a example, real example, that the most of the people, those are basically related to education or related to education field, they are basically use a particular pen, dot pen, for writing purpose. Now, what happened? Whenever we basically use a particular dot pen, then if ink is basically end, then what happened? What is the procedure of refilling this particular ink? That whenever we observe that our ink is basically end in our pen, then obviously we visit a particular book shop and we purchase a different pen, or we basically refill our pen. Okay. Now, what types of the problem we basically face in general? That during the some writing process, if our ink is basically end, then what happens? We require another pen. If we have another pen, that is okay. Otherwise, what happens? We basically face some problem. Okay. Now, suppose you just imagine that our pen is basically connected to internet. Okay, how it is possible, I will discuss. Now you just imagine that our pen is basically connected to a internet. Now, internet are basically monitor what is the ink condition of our pen. Okay, and now whenever that ink is basically going to end, then what happened? Internet basically analyze these things and inform to a particular person. Okay, those person are basically responsible for refilling our pen, and they basically come to us and said your pen ink is basically ended, I just refill it. Okay, then what happened? We basically avoid our previous problem. Okay, if we have no alternative pen or no alternative refilling procedure, then what happened in our previous case? That we facing some problem. That problem we basically avoid if our pen is basically connected to the internet, and internet basically analyze what is the ink condition of our pen, and automatically they basically inform a particular person, and person is basically coming in our office and refill our pen. Okay. Now, if we're talking about a simple pen, that pen is not connected to internet, this is not a smart pen. Okay. Now, whenever we just basically connect our pen to internet and all the things are basically going on automatically, then we can say it is a smart pen. Because what happened? That something automatically going on. Okay, that's why we said it is a smart pen. So that is the example of IoT. Okay, with the help of IoT, Internet of Things, we basically developed these types of systems. Okay. Now, the fundamental aspect of IoT is to unite every object of the world in such a manner that humans have the ability to control via internet. That is also a most important part. Whenever we basically connect a particular object to internet, then what happens? That human basically capable to control a particular object from remote location. Okay. This object also provide regular as well as timely up to date on their current status to its end user. Okay. Now what happened? If we just basically take our previous example, whenever our pen is basically connected to internet, then what happened? That shop owner are basically find that what is the condition of the ink. Okay, or someone basically observing what is the condition of the current ink in a particular pen. Depending on that, someone basically make decision. Okay, that now this pen are basically required to refill. Okay, that's why whenever we talking about Internet of Things, then in case of the Internet of Things, what happened? We basically change some physical parameter. Okay, for smart pen, we basically monitor what is the condition of the ink. Okay, if we're talking about the other application, then related to that particular application, we just change some physical parameter and make some decision. Okay, you can relate these things in our real life application. Okay, in our daily life, whenever we basically make some decision, then what happens? We basically observing some physical parameter. Okay, suppose that whenever someone are basically give a glass of water, okay, that water is basically cold or hot, that thing how we measure? We basically first observe this particular object. Okay, during the observation, what actually happening? We basically measure some physical parameter. Okay, that whenever we just basically touch the glass, then we can realize that particular water is cold or hot. Okay, and from our eye we can observe that this particular water is hot or cold. Okay, that means these are the different sensors that actually fit in our body. With the help of some sensor, that means neuron, we basically observe some physical parameter, and these physical parameter are basically processed in our brain, and after that we make the decision that particular glass of water is basically hot water or cold water. Okay, same thing is happening in IoT based system also. Whenever we basically connect a particular physical object to the internet, then some monitoring is basically done. Okay, that means some physical parameter is basically changed and processed. Okay, and whenever we basically process this thing, then IoT is a new computing facility with consisting of the features from network, device, and software. These are the different components that actually used to implement IoT concept. Okay. Now, whenever we're talking about the application of IoT, nowadays what happens that lots of application area are basically present where we can apply IoT to solve different real life problems. Okay. That nowadays what happened that the industrial management, that huge number of IoT systems are basically okay. If we're talking about the agriculture field also use so many IoT based systems that basically make traditional agriculture systems in an automated way. That means with the help of the IoT systems, we can change our traditional agricultural practice to a smart agricultural practice. Okay, and IoT also used for livestock management, smart city development, smart village development, home automation, healthcare. These are the different fields where IoT is basically used in large scale. Okay, excluding that, so many application areas are basically available where we can use IoT. Okay, now I have shown here one example where that IoT is basically used. Okay, that is the industrial management. In this particular picture, you can see that in the right side we have some old automobile industry. In old automobile industry, what happened that so many labor are basically engaged for assembling any car. That's manufacturing of a particular car in old automobile industry totally managed by human. Okay, that's why here this is not a cost effective solution and so many human error are basically present. Okay, now whenever IoT are basically coming into the market, then what happened? This particular automobile industry basically changed. Okay, now what happened? Everything within the automobile industry managed by IoT system. Okay, that basically reduced that cost. Okay, cost is the most important factor. Okay, and also reduce error, human error. Okay, because whenever that some labor are basically engaged for assembling a particular car, then so many error are basically present. However, whenever that particular system is basically automated, then what happens? These types of the error are basically reduced. So that's why here, that is the manufacturing cost are basically reduced by IoT system, and also that human error basically reduced here. Okay, now in this particular picture, I basically show that how agriculture is basically changed by IoT, Internet of Things. Okay, in previous time, what happened? We are basically using some cattle for agriculture purpose. Now what happened? Some machinery, automated machinery is basically coming for agriculture. Okay, that basically reduced cost of the agriculture. Okay, that's mean whenever we basically adopted some automated system in our traditional agriculture, that basically reduce production cost, and whenever the production cost is basically reduced, then what happened? That farmer are basically get more profit. Okay, nowadays what happened? In right side picture you can see this is our the future. In future how the agriculture is basically managed. Here a robot is basically operating some tractor, okay, for agriculture purpose. Okay, now that thing are basically whenever we basically adopt a particular new technology in our agriculture, that basically increase the production and also reduce the production cost. And whenever these two things is basically happening, then farmer is basically get more benefit. Okay, now this is a typical IoT application in smart village development, that most of the people are basically familiar with this terminology, that is smart city development. Now one concept is coming, that is the smart village development. Okay, in case of the smart village development, what we basically try, that we basically try to connect whatever the physical object are basically present in our village, then how we just connect this all physical object to internet. That's why what happened, whenever we basically capable to connect all physical objects those are basically present in village environment. Okay, once we basically connect, then we can control this all physical object. Okay, control, monitor, okay, manage effectively. These all the things are basically happening. Now, whenever we're talking about the smart village is basically little bit different compared to smart city development. Okay, now in case of the smart city development, what happened, that in a city that so many infrastructure are basically available. That's mean we have a good traditional network, cellular networks, we can use this cellular network to connect our different physical objects. Those are basically present in the city. Okay. However, in case of the village, we have so many different issues. Okay. That basically create problem during the connection of physical object to internet. Okay. That's why whenever we're talking about the smart village development, then smart village development is little bit different compared to smart city development. Okay, because most of the cases you can realize in village we have no good network connection, internet connection. Okay, that's why if we try to connect any physical object in our village environment internet, that basically create so many problems. Okay, so these types of so many issues are basically present in our village environment that basically make smart village development critical compared to smart city development. Okay, now most important thing that whatever the example I have told you regarding IoT, now most common question that basically coming into our mind, how it is possible. Whenever we're talking about the IoT, then how IoT is basically possible. That means if we want to develop a IoT based systems, then how we basically develop a IoT based system. Okay. Now, whenever we're talking about the IoT based systems, in a IoT based systems, a large number of sensors, surveillance cameras, switch, and other fixed devices will be installed. Okay. Now, these devices are basically used for capturing some real physical parameters, and these sensors, surveillance cameras, and other components that basically make a physical object smarter. Okay. That suppose that we have a particular pen. If we just basically take our previous example, pen, a normal pen. Whenever we're talking a normal pen have no capacity to sense that what is the condition of the ink. Okay, if we add a particular sensor within the pen, then that sensor is basically capable to measure what is the condition of ink. Okay, now if we add a transmitter with our pen, then what happens? The transmitter can capable to transmit this real information to our internet. That means with the help of transmitter, we can connect our pen to internet. Okay, so these are the different components that basically we use to make a physical object smarter. Okay, now sensor and device will be connected to the internet and produce huge amount of the data which can then be stored and processed on cloud server. Okay. Now what happens whenever we basically attach a particular sensor into a physical object, then what happens? That sensor are basically continuously monitor some physical parameter related to that particular object. Okay, now whenever sensor is basically measuring this real parameter, then what happens? Sensor is basically generate huge amount of data. Okay, now another issues that basically coming related to IoT, that where we basically store this huge amount of data. Okay, now this huge amount of the data we basically store in cloud server. Okay, cloud is basically a low cost solution. That's why we basically use cloud server to store this data. Okay, Now what happened, whenever we basically store this huge amount of data, now we require to process this data. Otherwise, we are unable to make any decision. Okay, that's why that data, whatever the data we basically capture by the sensing device, okay, or you can say by the sensor, this data first store in cloud server, and after that we basically use some intelligence algorithm to analyze this data. Once we analyze this data, we basically make a decision. Okay, so these are the different technology that basically used to develop a IoT based system. One technology, that is the sensor. Sensor is basically used to sense real life data. Okay, that's mean whenever we basically attach some sensor to a particular physical object, then what happens? The sensor basically captures some physical parameter. This is the one technology, that is the sensor technology. Okay, now what happens? How this data is basically transferred to our internet, where cloud is basically present. Then we require a proper networking. That network are basically help to transfer our data to internet. Now whenever data is basically coming in our internet, we use another technology, that is the cloud technology. Okay, that cloud technology is basically used to store the data. Okay, that is another technology that basically used in a IoT based system. Okay, now whenever data is coming in cloud server, then what happens? We require to process this data. On that case, what happened? We basically use some AI based algorithm. Okay, that is another technology we basically use in IoT system. And this AI based algorithm are basically analyze this data and make some decision. Okay, now whenever a decision is basically coming, then what happens? We require to implement this decision in real environment. Okay, it can be implemented physically, that's mean by a human being, or we can develop a automated system. That automated system are basically perform in our real environment as per the decision. Then what happens? Then we also requires some other devices, that is basically refer as a actuator. With the help of the actuator, we can implement any decision in real environment. Okay, so these are the different technologies that basically use to build up a IoT based system. Okay, IoT not basically made by a single technology. Okay, IoT basically made by so many different technologies. Okay, now I have written here, this data can be further be analyzed, that finest use using the big data analysis. That means whenever huge amount of the data are basically coming into the cloud, then this big data is basically analyzed by Hadoop software, like so many other software also available. Okay, we basically use this software to analyze this data. Okay, nowadays Python is also used to analyze this data. Okay, now in that particular picture you can realize how these things are basically happening. Okay, here in ground layer, in that particular picture, if you realize, that is IoT device layer. Okay, in ground layer, what happened? That different types of sensor are basically used to sense some physical parameter. Okay, and what happened? This physical parameter are basically transferred to internet. Okay, that here we have a top layer, we have a cloud. okay, where we basically store our real life data. We have an intermediate node. These nodes are basically used for fog computing. Okay, another technology is basically coming here also. We basically create a middle layer, okay, where some little bit processing are basically done. Okay, that also assist our IoT system. Okay, in ground layer a we have some IoT device. IoT device means that these devices are basically equipped with some sensor, and this sensor are basically send some data and transmit this data to cloud. Now in this lower layer, we basically use a very popular networking concept for data gathering purpose, that is the wireless sensor network technology. Okay, wireless sensor network we basically use in this particular ground layer, where the different sensor are basically installed. Okay, and this, with the help of the WSN, we are basically collect or gather data, okay, in a central point, and that point is basically connected to the internet. Okay, that's why whenever we're talking about the sensor network, then sensor network is basically acting in that particular layer, that's been ground layer. Okay, where there the different sensor based devices are basically used for data gathering purpose. Now we basically try to understand that I have already told you that the major component of IoT, okay, the technology that we have already discussed. Now what happened? What are the major components that actually present in a IoT based systems? That first component is physical object. Okay, obviously we require some physical object. Okay, otherwise what happened? How we send some physical parameter, okay, from a particular physical object. Obviously we require some physical object. This physical object we basically target to monitor. Okay, that's why that the physical object is a basic component of a IoT system. Okay, and after that some hardware component. Okay, that hardware component are basically used for data sensing purpose and data transmission purpose. That's mean some physical sensor. Okay, these sensor are basically used for physical parameter sensing, and obviously whenever we basically attach some sensor into a particular physical object, then what happens? This sensing data, whenever we just try to sense some physical parameter, then we basically use a particular board, okay, to manage this different physical parameter. Then obviously we require some microcontroller. Okay, that microcontroller are basically manage sensing information. Okay, now whenever we want to transmit this data from physical object to internet, then what happened? We require some communication module. Okay, that communication module are basically help us to transmit our real information to internet. Okay, and whenever we talking about the communication module, in case of the IoT systems, we basically use 6 low pan and low power machine to machine communication. These are the communication protocol that basically used in IoT based system. Okay, obviously another major component we basically use in IoT based systems, that is software. That all the things are basically managed through some software. Okay, that software also a major component of an IoT based system. Okay, so these are the major component in an IoT based system, that is physical object, hardware, communication module and software. Okay, now network technology that basically used, I have shown you one taxonomy based on communication networking aspect of smart village. That means whenever we're talking about the smart village, or other word you can say, whenever we're talking about IoT based smart village, then this particular smart village is basically a heterogeneous application of IoT. That means IoT are basically used in smart village environment for different purpose. Okay, that's why whenever we basically use IoT for different application purpose, then what happens as per the problem, then the communication technology is basically changed. Okay, network type also change. Okay, and some other things also basically need to add. Okay, that's why this classification basically you provide that how you select different communication technology as per your requirement. Okay, some of the cases what happened that we basically realize that we basically want a low range communication protocol. Okay, some of the cases we basically realize that we need a long range communication. Okay, some of the cases we basically realize a low cost solution. Some of the cases we basically realize that cost is not so much important. However, quality is basically important. Okay, because whenever we basically try to develop a low cost solution, then somehow we basically compromise with the quality, because till now we have no such higher technology that basically provide a low cost solution with high quality. Okay, some of the cases we still now try to achieve this. However, what happened that whenever we basically try to develop some low cost solution, some quality compromise is basically happening. Okay, that's why as per the requirement we basically select different technology to develop a particular IoT based system. Okay. So this classification is a basic classification that what types of the communication technology are basically available for IoT based system development, what types of the network are basically available. Okay, and what types of the that is future and emerging technology basically available we can use to develop a IoT system. Okay, offer services, what types of the services are basically provided by a particular IoT based system. Okay, mode of operation, requirement. Okay, whenever we just basically try to develop a IoT based system, then what types of the requirement are basically most important during the development of IoT based system. These things I have mentioned in this particular picture. Okay, now communication technology. Okay, that whenever we're talking about the communication, because communication is most important part of an IoT based system. That's why that what types of the available communication technology that is what types of the different communication technology we can use in a IoT based system, that I have basically shown here in this particular table. Okay, if we want low cost solution or low range communication, then we can use that the Bluetooth. Okay, that as per our requirement we can pick up any communication technology to develop a IoT based system. Okay, otherwise what happened that if we randomly pick up a particular wireless communication technology for IoT based development, then what happened, it's not provide a good solution in terms of cost, in terms of quality of service. That's why whenever we want to develop a IoT based system, then what happens, we require a concrete knowledge about the different technology that we basically going to apply in IoT based development. Okay. From this particular table you can understand that what types of the communication technology are basically available in the market. Okay, and what are the communication range. Okay, if we basically want short range communication protocol, that means in our application some short range data transmission are basically happening, then we can use a Bluetooth. Okay, and Wi-Fi we can use. Okay, if we want a long range communication, then LoRa, okay, 6LoWPAN, these are the all long range communication. GP, okay, these are the all communication technologies that can provide you a long range communication. Okay, now that an IoT enabled WS, wireless sensor network. Okay, now whenever we're talking about the data collection from different physical object, okay, then what happened as per our previous discussion, that first we basically attach, or first we basically deployed some sensor node in our lower layer. Okay, and these sensor node are basically capturing that real information, and after capturing this real information, this sensor node are basically transmit data to a particular center point. Okay, now this center point are basically transfer this information to our end user. Okay, now whenever we're talking about the lower level data capturing process, here we basically use a wireless sensor network. Okay, that sensor network is basically yes.
ability to learn new technology.
Yes. Have you any question, anyone?
गोष्टी पाहायला लागल्या तो पवनही सांगे म्हणजे आम्ही बाकी काही नाही पाहत म्हणून पण आम्ही बेसिक नॉलेज जे आहे ते आणि विद्यार्थ्याचा आणि कॉन्फिडन्स कॅन्डिडेटचा कॉन्फिडन्स व त्याची इच्छा आहे का विलिंगनेस आहे का आणि पोलाइटनेस आहे का कॅमेरा ऑन ठेवणे या सगळ्या गोष्टी
Anyone? Have you any question?
चेक करून घे ना
Hemant,
त्यांनी शिकतात त्यात
your voice is not clear, Hemant. Okay, then end of this discussion we will discuss. Okay, whatever your question, that we will discuss. Okay, now I just continue that whenever we just talking about the IoT enabled WSN, then that first we understand what is WSN. That WSN is basically that wireless sensor networks, that whenever we basically developed a particular sensor network, that network is basically capable to transmit the data from different sensor node to a base station. Now, what we have looked in our previous figures, where we basically discuss different layer. We have a ground layer where that the IoT based device is basically used. After that we have a fog layer. After that we have a cloud computing environment. Okay, now in ground layer what happened, that whenever we just basically attach some sensor into a particular physical object, then was one simplest way that each and every physical object, that means this physical object are basically equipped with sensor. This device directly connected to internet. That is one solution. This is a simple solution. However, if we basically want to connect each and every device, IoT based device, those are basically deployed in ground layer, then what happens, the cost is basically increased. This is not a cost effective solution. If we basically connect all the device directly to the internet, okay, that is a major issue. Another issue, that some of the cases that we have no such scope that where each and every device directly connect to the internet. Okay, that's why what happened, we have another technology. That technology, name of this particular technology is wireless sensor network. Okay, That network is basically help us to develop a cost-effective solution. Okay, that technology, that's mean it is a networking technology where what happened, we basically established a network, ad hoc network. Okay, and in this particular network, what happened, different sensor device, those are basically deployed in ground layer. Okay, these devices are basically use multi-hop communication and transmit their data to a central station. Okay, central station are basically connected to the internet. Okay, that's why this basically provide a cheaper solution. Okay, and another case where that infrastructure based networks, that means if we basically try to develop a IoT application in city, then there is a no problem that each and every place we basically have a high speed network, cellular network. Okay, however, in case of the village where that the cellular network is not so good quality, or some of the cases that cellular network is not present. Okay, on that case we can use a wireless sensor network. That's that sensor network, that whenever we're talking about the wireless sensor network does not need any support from cellular network. Okay, that network we can make easily using some transmitter. Okay, low cost transmitter. Okay, that is the important of wireless sensor network to make a IoT enabled system or IoT based system.
Hello,
Yes,
sir.
yes.
Sir, this wireless sensor network, which is enabled with IoT, as you are speaking, this is for smart city building. It would be the picture which you are demonstrating now is one blueprint for that, right? Which is being explained now.
Priyanka, you are not audible. Okay, can you increase your volume little bit? That basically help me to listen you.
Hello.
Yes.
Sir, this IoT enabled WSN, which has been used, which is the thing which you are explaining now for the building of smart cities, is cloud storage
Still
and
you
also.
have some sound problem. I am not audible.
Okay, okay, sir. I'll text
You
you.
are not audible actually. Can you?
Okay, okay.
Now it is okay. Now can you
Okay.
repeat your question?
Yes, sir. The thing is, the IoT enabled wireless sensor network, which
Yes.
you are giving this blueprint for the smart cities. This what would be the base station, the frequency, the radio waves, which is being which is planned to be deployed in the smart cities. The frequency and the bandwidth range, if it is on higher spectrum, then there are more radio wave transmission in the smart villages as well, right? Which is which will be harmful for any human being to live in that surrounding. So what step government is taking in deploying this base stations and the frequency range, what the sector it is taking up and how it is going to deploy? Can you elaborate and knowledge on this concept?
Now what happened, that whatever the communication frequency we are basically using to establish a particular wireless sensor network, this communication frequency is not harmful for any living organ. Okay, this is basically proved or checked by the government organization. Government organization are basically provide a particular frequency, that radio frequency we basically use for communication purpose. Okay, that's why I basically show in our previous I have shown you that this is the diagram. That means in that particular table you can see that what types of the communication technology are basically standardized and governed by the different government organizations or different international bodies. That whenever one communication technology are basically coming into the market, that whatever the frequency are basically used for this particular communication technology, this all the things are basically checked and tested. After that, a standardization is basically done. Okay, and after that, international bodies and government are basically authorized that you can launch this particular communication technology for application purpose. That's why.
So it has been authorized. So it is been authorized by the government and international bodies that it is not harmful for human beings who are on the surroundings.
Not harmful for human being. Okay, that's why that the
Because
standardization is basically
here
made.
I have seen that 2 to 5 kilometers range it is given for low RAN wireless area network, right? That one which is having the range of 2 to 5 kilometers means then the bandwidth will be the frequency will be higher, right? Some 800 megahertz it is. So I had the doubt in this point. That's why I had.
No, that is well tested and standardized. Okay, there is no harmful, because whenever something is basically related to human health, that is basically well tested, and after that these things are basically launched into the market. Okay, and if it is harmful, then government not permitted to launch this particular communication technology. Okay, that we are not using any frequency for communication purpose in as per our choice. Okay, whatever the choice are basically available, this is basically well tested and permitted by the government bodies. Okay,
Okay,
that's
but
why
the implementers will be the third party, right? Any third party companies will be implementing this, right? We won't be knowing from end to end how it goes. So that's the reason I asked, because the telecommunication industries who are going to take this contract and those who deploy this should have maintained the same protocol as well, right?
that there I told you that there is a no harmfulness. Okay, that is well tested. Okay.
Okay, thanks.
That if we talking about that cellular communication is some harmful. Some of the people said that the cellular communication is harmful. Okay, that is not any base. Okay, because these things are basically well tested by the different organization, and government also monitor these things. Okay, so that is not a any valid cause. Okay, now that whenever we're talking about the IoT enabled WSN, then IoT enabled WSN, we basically before going to discuss details about the IoT enabled WSN, then first we have a wireless sensor network. In case of the wireless sensor networks, that is simple WSN. In case of the simple WSN, what happened that we basically developed a particular ad hoc network where the different devices are basically transmit their data to a central base station or central server through multi-hop communication. Okay, multi-hop communication. And as per our requirement, that we basically use different communication technology in this particular network. Okay, generally what happened, we basically use GP communication technology in our wireless sensor network. Okay, now whenever we want to apply our wireless sensor networks in IoT application, then what happened, then some little bit improvement we basically want in normal WSN, because whenever we're talking about the normal WSN, then the performance of the normal WSN is not so high. Okay, that means we are basically use some low cost devices, low cost microcontroller or low cost data gathering board. Okay, and that's why we are not achieving so high performance that is basically capable to support IoT. Okay, and little intelligence also required to input in our general WSN that basically support a IoT based system. Okay, that's why whenever we're talking about the IoT enabled WSN is basically a high performance WSN with some intelligence features. Okay, that what types of the intelligence we basically introduce in normal WSN, that I will discuss little bit later. Now the basic difference between a IoT based WSN and normal WSN, that whenever we're talking about the IoT enabled WSN is a high performance WSN. Okay, and some little intelligence we also introduce in IoT enabled WSN. Okay, that means some decisions are basically made within the networks that basically help to implement, or you can say that basically help us to make some decision within the network. In case of the normal WSN, that all the decisions are basically made in the base station. Okay, and some of the cases that performance of the normal WSN not so high. Okay, that's why it is a, you can say that whenever we're talking about the IoT enabled WSN, and IoT enabled WSN is basically a higher version of normal WSN. Okay, that's simply you can say that it is a high performance WSN. Okay, now whenever we're talking about a sensor network, in a sensor network, that the basic component is sensor node. Okay, now that the original picture of the sensor node such like that whenever we're talking about a sensor node, that sensor node have a microcontroller. Okay, this is a block diagram regarding a particular sensor node. In this block diagram you can see we have a microcontroller. Okay, we have a transceiver, that means transmitter and receiver. These two things are inbuilt within that particular block. Okay, and this module are basically used for the data transmission or data receiving purpose. Okay, and what happened that whenever we're talking about the sensor node are basically equipped with different sensor. Okay, this sensor are basically used for sensing some data from the real environment. Okay, now we have a very little size of memory. Okay, and that memory are basically used to process the sensing information. Okay, and we have a power source. That power source is basically powered in this particular microcontroller. Okay, these are the different components that actually present in a particular sensor. Okay, now you can see this is a real sensor node. Okay, this sensor node are basically used for lab to develop a particular real life application protocols. Okay, and these are the sensor. Okay, this is the soil moisture sensor. This sensor is not capable to work individually, because if we only think that sensor are basically capable to sense the data and transmit this data, this is not true. This sensor is basically attached with this particular board. This board are basically refer as a node. Okay, and whenever we basically attach this particular sensor to this particular mode, then this sensor are basically start working. Okay, that's why together the sensor and this particular mode we basically take this is a sensor node. Okay, this sensor node are basically used to sense some physical parameters. Okay, related to a particular object, related to monitoring environment, that if we want to monitor some temperature of a particular area, okay, then we basically develop some sensor node. Okay, this node are basically capture the temperature. Okay, so as per the application we basically first configure our sensor node. Okay, and then we basically deployed the sensor node. After deployment, what happened? We basically this sensor node automatically identified all the other node, neighbor node, or other word you can say that with the help of the neighbor node detection, that deployed sensor node basically make a ad hoc network, wireless ad hoc network. Okay, and with the help of these networks, the deployed sensor node are basically transmit data to a central server. And in case of the IoT based application, that central server are basically, or central base station gateway node, you can say that gateway node is basically connect our sensor network internet. Okay, now these are the real IoT node. Okay, that these are the board, that is mode. Okay, and we basically attach some sensor with this particular mode. Okay, as per our requirement. Okay, these are the real board. Now, what are the challenging issues are basically present in IoT enabled WSN? That is the most important thing. Whenever we're talking about the IoT enabled WSN, that basically used for the data gathering purpose. Okay, then whenever we're talking about the IoT enabled WSN, some challenging issues are basically present. What are the challenging issues are basically present in IoT enabled WSN? That first one is the energy. Okay, because what happened that the size of the sensor node is very small. Okay, and a constant battery supply is basically attached with the sensor node. And whenever we're talking about the sensor network or IoT enabled sensor network, then what happened that the huge number of sensor nodes are basically deployed for monitoring a particular environment or monitoring some physical object. Okay, now what happened that the energy is the most challenging issue, because once the energy is basically discharged in the sensor node, that some of the cases it is very difficult to recharge. Okay, and some of the cases we basically recharge this device if we talking about the indoor application. In case of the indoor application, we can use that the recharging process. However, that if our application is basically running in outdoor environment, and that the huge number of sensor nodes are basically deployed to monitor a particular area or to monitor some physical object, then it is very difficult to recharge each and every device. Okay, that's why what happened, we basically require to save energy. Okay, and if we capable to save the energy of the sensor node, then what happens, then the lifetime of the sensor network is basically increased. Okay, because that whenever energy consumption are basically reduced, then our network is basically work for a long period of time. Okay, that's why energy is basically a important challenging issues in wireless sensor network or IoT enabled WS. And another things that I have already told you, in IoT enabled WSN or normal WSN, what happened that each and every device basically transmit their data to the base station via multi-hop communication. Okay, and whenever we're talking about the multi-hop communication, then what happened? We require a proper data routing protocol. Okay, data routing protocol. Data routing protocol are basically increase the transmission speed. Okay, that means that the transmission delay is also an important factor. If we basically want to develop a real uh, real life application, that means where that the some real parameter are basically transmit to our base station, and base station process this data and basically make some decision, then the transmission delay is most important. Suppose that we want to develop a IoT based system that basically monitor the fire condition of a building. Okay, then what happens if our routing protocol are basically take so much time for data transmission, then what happens, then that fire is basically spread throughout the building. Okay, on that case what happened, we basically require a faster data routing protocol. Okay, if we have a faster data routing protocol, then what happened, that immediately our system is basically detect that some fire is basically within the building and automatically generate a signal or alarm. Okay, that's why some of the applications are basically require faster data routing protocol. And in wireless sensor network or IoT enabled sensor network, whenever we basically try to develop a faster data routing protocol, then what happens, some little bit more energy is basically consumed. Okay, now still now we basically try to develop a energy efficient faster data routing protocol. Okay, and some of the cases what happens, some of the application, then we don't require faster data transmission. Okay, that if little bit some delay is basically present, then it is also okay. On that case, energy is most important. Okay, that whenever we just try to develop a little bit delay oriented data routing protocol, that may be energy efficient. Okay, some of the application, that means that these challenges are basically varied with respect to different applications. Okay, and another case, that the fault detection and fault recovery in wireless sensor network, what happened, that the fault occurrence probability, okay, is much more compared to traditional network. Traditional network, that's mean our LAN, wire based LAN. In wire based network, that the fault occurrence probability is very less compared to our wireless network. Because what happened, that wireless network is basically that basically wireless sensor network, that basically working in a outdoor environment. And whenever we're talking about this particular wireless sensor network, that so many different physical that means environmental barrier are basically present, and due to this barrier, that fault occurrence probability in sensor networks are much more compared to traditional network. That's why we require to develop a particular fault tolerance protocol that basically handle whatever the fault are basically occur within the WSN during the data transmission process. Otherwise, what happen, if we are not applying any fault tolerance and techniques in our wireless sensor network, that basically reduce that the quality of services. Okay, that's why what happened, whenever we're talking about the IoT enabled WSN, in case of the IoT enabled WSN, we basically install some fault tolerance data routing algorithm that basically increase the quality of service. Okay, now another challenging issues that actually present in IoT enabled WSN, that is the obstacle detection and avoidance. Because whenever we're talking about the IoT enabled WSN application in outdoor application, then what happens, then so many physical objects are basically present in outer environment. In case of the indoor application, so many obstacles are basically present, because obstacles such like that a large size tree, okay, a hill, or if we're talking about the indoor application, then what happened, then wall, these are the physical obstacle. Okay, this obstacle is basically preventing that the communication, because in case of the wireless sensor network, we basically use a low range communication protocol. Okay, generally we basically use a low range communication protocol. Okay, and that's why this communication frequency, whatever the communication frequency we basically use in wireless sensor network, that things are basically prevented by the obstacle. Okay, and that's why that one obstacle avoidance algorithm also very important for wireless sensor network, that basically increase that the quality of service. Because if we basically installed a particular obstacle avoidance protocol in wireless sensor network, that basically reduce fault in our networks, and whenever we basically reduce fault within the network, that basically increase quality of service. Okay, and coverage problem, congestion control, load balancing, these are the other challenging, major challenging issues. Those are present in wireless sensor network. Okay. Now, whenever we're talking about the data gathering, okay, data gathering, basically what happened that in previous time we basically use the centralized data collection process. In case of the centralized data collection process, what happened that whenever we basically deployed some sensor node in a monitoring area, this sensor node directly transmit their data to the central server or base station or gateway. Okay. On that case, what happens that the energy consumption of the node are basically higher. Okay. Whenever we're talking about the centralized data collection scheme, in centralized data collection scheme, that the energy consumption rate of the sensor node is basically high, because the energy consumption of the sensor node is basically depending on the transmission range. Okay. In case of the central data collection process, that each and every node directly transmit data to the base station via single hop communication. That's why energy consumption rate of the network is basically high. That's why what happened in 2001 and 2002, that one very popular concept is basically introduced in our wireless sensor network field, that is the clustering, that basically reduce the energy consumption of the sensor node. Okay, clustering technology said that instead of direct transmission to the base station, that when we basically deployed sensor node in a monitoring area, the sensor node first logically divided into different groups. These groups are basically referred as a cluster, and each and every cluster basically have a cluster head. Okay, and cluster head is basically collected data from other cluster member node. Okay, and this cluster head basically transmits the data to the base station. Nowadays, most of the application is basically used cluster-based data routing protocol. Okay, in cluster-based data routing protocol, what happened that after sensor node deployment, that sensor node are basically divided into different logical group. Okay, this group are basically referred as a cluster. Okay, and each and every cluster have a cluster head, and that cluster head are basically collect data from the different sensor node and transmit this data to the base station. Okay, here what happened that the sensor node are basically transmit their data to the SIM node or base station or gateway node via multi-hop communication. Okay. Now, whenever we're talking about the cluster-based data gathering process, in cluster-based data gathering process, we have so many other issues. Okay. Now, other issues such like that, in this particular picture, you can see, that what happened whenever we're talking about the cluster-based data routing process. In cluster-based data routing process, that what I have told you that first after deployment, all the sensor node are basically divided into different group. That group are basically referred as a cluster head. Cluster head basically collect data from the other cluster member node and transmit this data. Now, whenever we just implemented this particular clustering concept, then that the energy dissipation rate of the sensor node are basically disbalanced. Okay, that means I have already told you that energy consumption rate are basically depending on the transmission rate. Okay, if transmission range are basically increased, then the energy consumption rate are basically increased. If transmission distance is basically reduced, then energy consumption rate also increase. Now, whenever we make a group or cluster, then cluster member node energy consumption rate are basically reduced. Okay. However, that the cluster head energy consumption rate is basically increased, because cluster head basically receive data from the all cluster member nodes. Okay. During the receiving process, that the cluster head also consumes some energy. After that, this data is basically transmitted to other nodes. All this data. Now, during the transmission, what happened? Then the cluster head also reduce some energy. That's why what happened, whenever we just basically implemented clustering concept as well as the multi-hop data routing concept, then the energy consumption rate of the deployed sensor node are basically disbalanced within the network. And whenever the energy consumption rate of the deployed sensor node are basically disbalanced, then what happened? Then some of the node are basically died early compared to other sensor. Okay, because the transmission and receiving load of the sensor node are basically different within the deployed sensor node. Okay, and that's why what happened, whenever that the energy consumption rate of the deployed sensor node are basically disbalanced and some of the node are basically die early, then what happened, that a network partitioning problem is basically coming. Okay, network partitioning problem means that in this lower picture you can realize some of the red node are basically present. These red node are basically died, and that blue node are basically still have some energy, and these node are capable to transmit the data to the base station. Okay, however, due to absent of data transmission path, because here what happened, that the multi-hop data transmission is basically occur. That's mean one node transmit data to the next level node, and next level node transmit this data to the next level node in such a way that the data is basically reached to the base station. Okay, now whenever this node are basically died, then what happens, this node are that the blue node are basically disconnected from the base station. Okay, and that's why what happened, this network is totally going to dead condition. Okay, due to absence of efficient data transmission path. Okay, that whenever this network is going to dead condition, in dead condition what happens, some nodes still alive, they are capable to transmit the data. However, we are not utilize this node because our protocol is not balance the energy. That's mean if all the node are basically died in a particular same timeline, okay, then what happens, then we can utilize all sensor node energy. Okay, now in that case we are not capable to utilize all sensor node energy. Okay, now this is a major problem. Okay, that things are basically happening, these types of the problems are basically happening due to premature death of the node. Okay, premature death means that here what happens, some node are basically died early due to high load, and some node are basically still alive. However, due to inefficiency of data transmission path or absence of data transmission path, we are basically treated this node as a dead node, because total network is basically going to dead state. Now, for solving this particular problem, we have proposed a particular data routing protocol. Okay, this protocol are basically referred as a green cluster based routing scheme for large scale wireless sensor network. Okay, these types of the problem are basically seen in large scale network where huge number of sensor nodes are basically deployed, densely deployed. Okay, now I just try to describe the solution briefly. Okay, I'm not going to details because these are not, this is so time consuming. Okay, that's why what happened in that particular solution, we basically divided, or you can say that we basically categorize all sensor node into different categories with respect to their remaining energy transmission distance. Okay, these are the two most important parameter. Depending on these two parameter, we basically categorize all the deployed sensor node into different categories. Okay, and after categorization, we basically select strong node. Those are the communication range are basically less, or remaining energy is basically high. Okay, these node are basically select as a cluster head. Okay, and after that again we basically select another types of node, that is the traffic node. If some cluster head load are basically so high compared to a cluster member node, then we basically select a middle node. That node are basically referred as a traffic node. That traffic node are basically used to balance the energy consumption of the cluster head and cluster member. Okay, and if we capable to balance this energy consumption rate of the cluster head and cluster member node, then what happened, we basically avoid these types of problems. Okay, that is network partitioning problem. Okay, now these are the objective regarding that particular problem. Okay, that is, first we said that the total, first we calculate the total energy consumption of the networks. Okay, and that total energy consumption of the network must be minimized. That is our objective of the paper, or objective of this work, because whenever we talking about the sensor network always need a energy efficient data routing protocol. Okay. That's why first we said that how we reduce the energy consumption of whole network. Okay, and total energy consumption of the network is basically calculated by this formula. There, here what happened, we basically use the transmission distance and receiving energy loss. Okay, and very little bit energy are basically consumed for sensing purpose or processing purpose. These all the things we basically consider here, and we just calculate that the total energy consumption of the networks. And in first objective we basically said that we must use that the minimum energy for the data transmission. Okay, that next thing is the control message reduced. Okay, control message in sensor networks, we are basically using two types of message. One is the control message, another is the data message. Control message are basically used to establish the network. Okay, establish the network. That what is the meaning of the establish of the network? That in case of the wireless sensor network, whenever node are basically deployed, after deployment, what happened? Node sorry, node are self-organized. That means after deployment, each and every node detect their neighbor node, and with respect to the neighbor node, they are basically decided or identified data routing path. Okay, that's why during that the network establishment phase, that means whenever sensor node basically detected their neighbor node and identified a data transmission path, these all the things, total network management is basically done through some message purpose, messaging. Okay, these messages are basically referred as a control message. Control message basically used to control our networks, because whenever we use a wireless sensor network, that wireless sensor network totally managed and controlled by via some message passing. There is no human being are basically present. They are basically manage this network. That the everything are basically managed via exchanging some message. Node are capable to transmit some control message and basically establish some protocol or topology for data transfer. Okay, that's why that the control message is not holding any original data. Okay, that control message only used for network establishment and controlling purpose. That's why if we just reduce that the control message, then what happens? Then we can minimize the energy consumption of the network. Okay. That's why that is also another objective of this work, that how we just reduce the control message. That means using minimum control message, how we just basically manage our total networks. Okay, manage or control the total network. That is another objective of this work. And the traffic load that is basically related to the cluster head. That means what happened, that whenever all the cluster member node are basically transmit the data to the cluster head, then huge traffic are basically create within the cluster head. Okay, then we basically set another objective in this particular work, that how we just handle this huge traffic load that basically generate in cluster head. Okay, and after that finally we basically set another objective for this work, that is the load balancing. Okay, that I have already told you that the load, that means transmission load and receiving load, in our cluster head is much more compared to cluster member node. Okay, that's why the energy consumption rate of the cluster head is much more compared to normal cluster member node. Then how we just balance these things? Okay, that is another object of this work. Now what happened in this case, what we basically implemented, what thing we basically implemented to achieve this all objective, that we basically categorize all the sensor node into different category using fuzzy rule set or fuzzy interference engine. Okay, using this particular fuzzy interference engine, we basically categorize all the deployed sensor node into 3 different categories. Okay, here I have mentioned that one category is the strong node, another category is the moderate node, and last category is the weak node. And this categorization are basically done on the depending on the transmission range, okay, and that the traffic load, okay, and remaining energy. Okay, and strong node basically represent those nodes those have the higher remaining energy, less transmission distance, and that the load traffic load is basically minimum. And whenever we just basically try to select as a cluster head, okay, whenever we just select a cluster head, we basically select cluster head from the strong node. Okay, and if strong node is not present within a particular group, then we select cluster head from moderate. Okay, these are the medium category node, where that the remaining energy of the node is not so high as compared to the strong node and not so weak as compared to weak node. Okay, that's why if the strong node are not present within a particular group, then we basically select a cluster head from the moderate. Okay, and weaker node, those nodes have very little amount of energy, okay, and high traffic load. These nodes are only responsible for data transmission. That means this node only acting as a N node. N node means that these nodes are basically a sense parameter and transmit this parameter to the cluster. These nodes are not receive any data from the other node. Okay, that means these nodes are not working as a routing node. Okay. So depending on these 3 categories, we basically manage our whole network. Okay, that means whole data transmission or data routing process are basically managed on these 3 nodes, depending on these 3 nodes. Okay, and here I have mentioned some packet format. Okay. Here, these things are basically divided the total time slot into time period into different slot. Okay. That how the that first is node classification is done. Okay. That how our proposed protocol are basically working. That thing are basically present in this particular figure. First, what happened that the node classification is basically done. After that, what happened that the cluster phase is basically cluster formation is basically done. And once the cluster is basically formed, then what happened? Then that the data routing is basically going on. Okay. Up to cluster formation phase, that all the data, all the message, those are basically transmitted by the deployed sensor node. These message are the control message. Okay. One cluster formation phase basically completed, then the data transmission are basically start. Okay, and this is a one cycle. Okay, and after some cycle, what happened? Whenever that the cluster head are basically detect, its energy is basically going to a less compared to a threshold value. Then what happened? Cluster head basically again start the cluster node classification process, because after some time what happened that all the node status are basically changed. Okay. Whenever some data transmission is basically going on, then the energy remaining energy condition is basically change of the node. Okay, and that's why what happened that again the node classification is basically going on, and again the same procedure, that node classification, after that cluster formation, and after that again data transmission are basically going on. Okay. These two things are basically refer as a setup phase, that is the node classification and cluster formation. Okay, that after some periodic time interval, this particular setup phase are basically executed within the network. Okay, that basically preventing premature death of the network. Okay, that in this particular picture you can see that after classification how the node look like that. These are the strong node. These the blue node are basically strong node. Okay, and green node are moderate node. Okay, and pink node are the weaker node. Okay. These are the different node after classification, and depending on these things we basically set up our cluster. Okay, now that the cluster formation message, that different message, those are basically used in this particular work. This message format I have shown here. Okay, I'm not going to details about this thing. Okay, here is the another message format that basically used. Now is the efficiency of our proposed scheme. And whenever we basically propose a particular algorithm or particular protocol for our wireless sensor network, that particular efficiency of that particular protocol are basically calculated or analyzed mathematically depending on the complexity. Okay, that is the message complexity, time complexity, network lifetime. That means how our proposed scheme are basically increase the network lifetime. Okay, that things we basically analyze by these three lemma. Okay. Now most important things, whenever we just propose a particular solution with respect to a particular problem, then we require to analyze that the effectiveness of the proposed scheme compared to the existing one. Okay, now to evaluate this particular proposed scheme, we basically consider the residual energy of the networks. In these two scenario, okay, you can see that the total residual energy of the network is much more compared to other existing techniques. Okay, that in scenario is a large scale scenario where that the huge number of sensor nodes are basically deployed, and scenario one where the network size is basically less, where the minimum number of sensor nodes are basically deployed. 100 sensor nodes are basically deployed, and in case of the scenario 2, that their 3000 sensor node are basically deployed. And in these two scenario, you can see that the energy consumption rate of our proposed scheme is less. Okay. Now, average energy consumption of the cluster head, okay, that we basically analyze that how the energy consumption of the cluster head is basically balanced. Okay. In the previous existing techniques, you can see that the cluster head energy consumption rate are very dynamic. Okay, that means one, the cluster head energy consumption rate is basically high, and some of the cases cluster head energy consumption is less. Okay, that basically create imbalance in the network, energy consumption imbalancing in the networks. Okay, now you can see in our proposed scheme that the energy consumption rate of the cluster head is little bit balanced, okay, compared to previous existing scheme. Okay, something we cannot basically define the energy consumption rate of cluster head in a straight line. Okay, because what happened, I have already told you that the energy consumption rate are basically depending on the transmission rate. That's why that we basically balance energy consumption rate up to a certain level. Okay, and we cannot balance our energy consumption rate of the sensor node in as per a straight line. Okay, that's mean we cannot say that all the cluster head energy consumption rate are equal, because it's totally depending on the transmission rate. Number of alif node, that also another parameter that we basically use to evaluate our proposed scheme. That number of alif node in our proposed scheme is more compared to other existing scheme. Okay, and that is the another comparison result. Okay, where we basically compare first node die, half node die, and last node die. Okay, these things are basically compared with respect to other existing techniques. Okay, average energy consumption rate, these are the different parameters that basically we have used to evaluate our proposed scheme. Okay, average latency. Okay, in our proposed scheme, that the latency, the data transmission latency also less compared to other existing schemes. Okay, data delivery ratio. Now another most important scheme that we basically propose to solve this particular premature death problem. Okay, in our previous proposed scheme, we basically use static node. Okay, all the node are basically static. Static means that once sensor node are basically deployed, then the deployed node are not capable to change their location. Okay, they are fixed. Now here we basically introduce a new concept, okay, that is the mobile SIM based data gathering process. Okay, in case of the mobile SIM based data gathering process, what happened that most of the all the deployed sensor node are basically static. We introduce some mobile node, okay, the few number of mobile nodes that basically visit different location and collect the data from the deployed sensor. Okay, and that basically also reduce the energy consumption of the deployed node. Okay, now however, whenever we're talking about mobile SIM based data gathering scheme, mobile SIM based data gathering scheme have some limitation. Okay, that mobile SIM based data gathering scheme we capable to implement for some specific application. Okay, not for all application we can apply this mobile SIM based data gathering scheme. Okay, however, if we're talking about that is static SIM based data gathering process where all the things are basically static, that algorithm we can apply for any application. However, that the energy consumption rate in the static scene based data gathering process is more compared to mobile scene based data gathering process. Mobile scene based data gathering process is more efficient compared to static scene based data gathering scheme. Okay, that I have told you in previous scheme. Okay. Now what happened in case of the here in this particular scheme, or you can say in this particular work, we basically use a mobile scene based data gathering scheme. Okay, and that basically reduce that the energy consumption of the networks, and that also help to balance the energy dissipation rate of the deployed sensor node, and that basically preventing the network partitioning problem and also preventing that premature death of the node. Okay. I briefly describe how this particular proposed scheme basically works. Okay. Now what happened that mobile sync is a device that move into the network and collect data from the sensor node. Okay. Now you can see in this particular figure we have a mobile device. That mobile device are basically move within the network and gather the data from the deployed sensor node. Okay. Now whenever we are talking about the mobile sync based data gathering process, for faster data gathering we basically require a proper data gathering management policy. Okay. That how the mobile sync are basically gather data from the deployed sensor node. That's why what happened, we basically select some individual point. Okay, this red point basically shows some individual point, or a simple way you can say these are the station. Okay, you can say these are the station where mobile sync are basically stop and collect the data from the nearest deployed sensor node, and after collection what happened, that mobile sync move to next station. Okay, where the station is basically referred as a rendezvous point. Okay. And again here mobile sync basically stop and collect data from the surrounding sensor node, and after collection again move towards the next rendezvous point. In such a way what happened that the mobile sync collect data from the all deployed sensor node, and end of this particular data gathering tour, that say mobile sync reach to base station. Okay, this is the base station, and base up and download all the collected data to this particular base station. Okay, that is the simplest. Now here challenge is that how we basically select this all individual point in optimal way. Okay. Here we basically use some intelligence techniques or AI based techniques that basically select optimal number of individual points, because if number of individual points are basically increased within the network, that basically increase the data collection time. Okay, data collection time. That's why in this scheme we basically use some AI based techniques. That AI based techniques is basically help us to select minimum number of individual point within the network, and after that we also apply Gray-Wolf optimizer or optimization techniques that basically identified optimal path between these all individual points, because optimal path also a important part that basically help us to reduce data gathering time. Okay, so these are the steps. Okay, how this particular proposed scheme are basically work. First is the setup phase, and after that intelligent data gathering phase. Okay, that we basically select that minimum number, optimal number of individual point within the networks, and after that we basically select a optimal path between all the individual points. Okay, so these are the some important theory related to this particular proposed work. I'm not going to the details about this all formulas because it also takes some time. Okay, that how we calculate that the maximum average intermediate hope count, okay, maximum average distance. These are all the things I have defined here. Okay. Now these are the some result that basically shows that the effectiveness of our proposed mobile SIM-based data gathering scheme. Okay. Now in first figure you can see that the sustainability of the node in our proposed scheme is much more compared to other existing scheme. Okay. And in network lifetime, with respect to the network lifetime in our proposed scheme is more compared to other existing techniques. Okay. Similarly, whenever the energy consumption rate are basically reduced, then the network lifetime is basically increased. That's why that we have also calculated the energy consumption of the node. Okay, that the average energy consumption of the node in our proposed scheme is less compared to other existing. So these are the different results that basically shows that the effectiveness of our proposed scheme. Okay. Now how IoT basically used in real life application. This is the one patent that basically um, that is published. It's an Indian patent. In that particular work, what we have done that we are basically used IoT enabled WSN for machine health monitoring. Okay, I briefly describe that how these particular things are working in real environment. Here, what happened? We basically use some IoT based device, sensor based device. Okay, these devices are basically capturing some real parameter related to a particular machine, and this real parameter is basically transmit to our cloud server via flab node. Okay, gateway node. Flab node means here is a coordinating node. Okay, coordinating node are basically coordinate that how the data is basically captured by this deployed sensor node and how this data is basically reached to that particular flab node. Flab node basically transmit this data to the cloud server via gateway node and internet. Okay. Here we also use a traditional network using capacity also present, and if you have no traditional internet, then we can use a Wi-Fi communication technology to connect our gateway node to the industrial cloud. And industrial cloud are basically analyze this all the real life data, and depending on the real life data that the cloud server are basically decided that any maintenance is basically required within that particular machine or not. Okay. Now that related to this work, that use case diagram, that where the different processes are basically executed and what are the different modules that actually use in this particular work that I have mentioned here, and how the system is basically working, that I basically try to show in this particular figure. That the system initialization, after that what happens, schedule, sensing, monitoring, data transmission are basically done. Okay, data is basically reached to the that is industrial cloud. Okay, after that what happens, data analyze, data is basically in this format, and we require to analyze this data to make some decision. Okay, the data is basically analyzed. After that what happens, if any fault is basically present within that particular data, that means data is not so good to make a decision, then what happens, then again resensing are basically done. Okay, these all the things are basically done within this particular system. Okay. Now that is the IoT enabled machine health monitoring systems, that different tasks, how these different tasks are basically executed, that things I have mentioned here. That is that navigation, deletion of data. Okay, that how the data is basically managed, how the process, how the data analysis process is basically going on, sensing. Okay, now that is also another real life application of IoT. That in this particular application, what happened? We basically developed a pest control system, IoT based pest control system. In this particular pest control systems, we are not using any pesticides. Okay, totally it is pesticide less pest control system. Okay, here what happened? We are basically used some solar energy for pesticide control. Okay, and as per this particular device, what happened? What types of the pests are basically attacked in a particular crop? That thing also monitor. Okay, this is also one real life application of IoT that actually we have developed in our lab. Another most interesting application that we have developed in our lab, that is the cow health monitoring system. In this particular system, what happened? We basically developed a cow belt. Okay, in previous picture you can see that there is a cow belt, and that particular belt have some physical sensor. This physical sensor are basically used to monitor different physical or health related parameter of a particular cow. Okay, and these devices are basically sense different physical parameter, health parameter of a particular cow, and transmit this data to the central server. Okay, now central server is basically analyze this data, and after that central server is make the decision if this particular cow is basically need a special care or not. Okay, if any abnormality is basically detected by the central server, then what happened? Then one message is basically going to veterinary doctor with the real physical parameter. Okay, that actually basically captured by the system from a particular monitoring cow. And veterinary doctor is basically again verify this all the data, and after that if veterinary doctor realize that this particular cow is basically require a special care, then what happened? Veterinary doctor are basically instructed field worker that this cow is basically require a special care. Okay, and that system also capable to identify a star of a particular cow. Okay, that means when this particular cow is required to taken care. Okay, these things all the things are basically used for dairy farming, and that also basically published in the patent. Okay, now I just stop here. I hope that the time is basically going to over, and if you have any question, then you can ask anyone.
So, participants, if you have any question, you can ask.
Hello, sir.
Participant, you are welcome to ask questions.
Sir, can I know can
Please speak louder, madam.
can we use which can I know which tool can we use for implementing
And
IoT?
otherwise, what happened? If you have any question, then you can also mail me.
Okay, sir.
Okay, I have mentioned here my email ID. If you have any question, then you can also mail me. Okay, separate. I will definitely answer.
Hello.
Yes.
You,
Anyone?
no, I'm asking to participants.
Dr. Mukherjee, then shall I leave?
Okay, sir. Thank you. We are privileged to have you with us, and thank you for your nice talk and in-depth knowledge distribution to the participant. Okay, so we are very thankful that you have taken out some valuable time for this session. Thank you, sir.
Thank you, Dr. Mukherjee.
Thank you. Okay, sir.
And
Thank you.
I wish you best of luck for this FDP.
Thank you, sir. This is the last day. So
Acha,
hopefully
acha.
we'll be conducting FDP soon. So I'll be keeping in touch with you. Okay, for next FDP also.
Okay, okay. Thank you, Dr. Mukherjee. Thank you.
Thank you, sir. So dear participants, the next session will start from 12 o'clock. Okay, Professor Satish Peduju will be taking a session on challenges on security, cyber security and all from IIT Roorkee. So please join, come back at 12 noon. Thank you.